Welcome to another video in the series about the C7000 compiler. This video explains redundant loops. When a redundant loop is generated, that usually means there is an opportunity to improve performance and reduce code size. My name is George Mock and I'm your guide. Why is it important to understand redundant loops? Well, the C7000 depends on software pipelining of loops to achieve maximum performance. Sometimes the compiler is forced to emit something called a redundant loop. And this video is about, well, what's that? Why is it bad? And we'll explain that it means that the loop can run a lot slower and your code size has gone up. And, well, what's the best way to avoid this? What do you do about it? To introduce the concept of redundant loops, I will use an example. And I'll begin by showing you this source code. We don't need to understand it in a great deal of detail, just a few things. There's a single function in this file, just one function. And this function has two loops, an outer loop and an inner loop. And you see this interesting syntax here. That's an attribute for the must iterate. Tells the compiler properties about the loop, and I will be covering that in some more detail. So dismiss this file, and I'm going to build it. This is the command I will use to build it. All of these build options have been reviewed before in other videos. I'll point out that source interlist means, among other things, that the assembly language file generated by the compiler is kept. So let's run this command. And now let's look at the assembly code that was generated by the compiler. And I'm going to take you down to, here's the beginning of the software pipeline feedback information, and I'm going to get into a detail there. And this is the detail I want you to focus on: redundant loop generated. This is how you know a redundant loop happened. It's right here in the feedback, plain as day. Okay? So now I can dismiss this file. Another thing I'm going to do is this command. Let's go ahead and run it, and then I'll explain what's going on. This runs a utility called OFD7X, stands for Object File Display Utility. And ultimately what I'm doing is I'm highlighting this is how much code space is used by the one function in this file. So the Object File Display Utility, with these options, that restricts the output to information about the sections. The only section we're interested in this particular case is the .text section. That's the section that contains all the instructions. All the rest of these sections contain metadata that are just not interesting right now. So this command runs all that through the find string command, and what that does is it'll only show you all the lines that have the word size or text on them, and there's one of each. So let's run this command and you'll see what I'm talking about. So we'll come back to this later. All I'm establishing right now is that the code size of this function right now is hex 380 bytes. We know a redundant loop was generated, and now I'm going to use some pseudocode to flesh that out to get you to understand what that means a bit more. So this is pseudocode that is representative of the assembly code generated by the compiler. Okay, so let's start with, this is I equals rows and L1, and then here at the end, if I, my decrement I go to L1, that's the outer loop. Okay, and then everything inside of L1 to L3 here, that's the inner loop. Okay, so the inner loop starts with J equals columns, And then if j is greater than 3, go to L2, where you'll do a software pipeline version of the loop on j. It'll run j times, and it'll be the software pipeline one. And this is the one you want to run because it runs fast, okay? But let's say j is less than or equal to 3. This conditional test will fall through to the slow loop on j. This is not software pipeline. It runs, some 10 to 20 times slower, and then when it's done, you branch around to L3 to pick up the outer loop again. Okay? So this is a pseudocode representation of the assembly code generated by the compiler, in this particular case of a redundant loop. So where are these redundant loops? Well, this is the one you want. This is the redundant one that you don't want. Okay? This is what we're talking about, redundant loops. Back in our example, I want to look at the assembly code. So let's bring that up. Go back down to, here's the beginning of the software pipeline feedback. And I want to focus on, I've already showed you this line about the redundant loop. Now I want to focus on this line, and let's talk about this a little bit. The software pipeline feedback shows the minimum safe iteration count, which is the minimum iterations required for correct execution of the loop. We're talking about this number here in the specific case of our example. This number is calculated after software pipelining is complete, which means this number counts in terms of the generated assembly and not the original source code. This is because this is computed after things like unrolling, vectorization, and so on happen, and that can change how the generated assembly counts iterations. Now, in our specific case, it turns out there is no difference. The source code, how the source code counts iterations and how the assembly code counts iterations is a match, but that's not always the case. This can make things a little bit difficult, but that's how it works. If for some reason the compiler is unable to guarantee that the loop executes at least, in this case, 4 times, what happens? Another loop is generated. And we saw that in the pseudocode I showed a few slides ago. Okay, there were 2 loops in there on j. Okay, and the redundant one is not software pipeline. The one that I called the slow loop, it's not software pipeline. And remember the little branch, the test and the branching that was happening inside the outer loop? That was the code to choose between the 2 loops that is added before both those loops. Remember there was this, if j is less than 3, do this, or j, I can't remember the exact, but it was something like that. Okay, there's code to make that choice, and that code is, executes at runtime every time through, in this case, the outer loop. Next, I show how to fix this redundant loop, and what we're going to do is edit the source code. Okay, and we're going to focus on this must iterate attribute right here. Right now it tells the compiler that the inner loop is guaranteed to execute 1 time. And remember, the minimum safe iteration count for this inner loop is 4, so we're going to change it to 4. Now keep in mind, this is just for this demonstration. We're changing it to 4. I'll talk about the wisdom, or rather the lack of wisdom, of doing it this way here in a little bit. But for right now, let's save the file. We're changing it to 4 just to see, well, what does that do? And we're going to rebuild. This is the command. We're going to rebuild and see what happens. Now let's inspect the assembly code. Right there. And Let's go down to the software pipeline feedback and get a look at things. There it is. Look, the redundant loop comment is gone. It's just missing, right? So it's just not present anymore. That means there is no redundant loop. So this means one of the ways you can look for this is just search for the word redundant in the source code generated by the compiler. So let's dismiss this file. Another way to see this is by looking at the code size. Remember, I used OFD7X to look at the code size. And remember, it was hex 380 bytes before. What's it going to be now? Hex 2C0, much smaller. This happens because the redundant loop is not there anymore. It makes the code size a lot smaller. Here are some details about must iterate. There are two ways you can write it. The first way you can write it is as a pragma, and that's true for C or C++ source code. For those of you who are writing in C++, you can also write it as a attribute like this. And that's how I did it in the example in this video. I have a slight preference for the attribute version because it's really easy to write a macro that wraps the attribute. It's possible to write a macro that wraps the pragma, but it's a bit more tricky, and so I just prefer doing it this way. What does this pragma or attribute say? Well, it tells the compiler properties of the loop iteration count. What properties are we talking about? Well, the first number, the min, says this loop iterates at least this number of times, whatever the number may be. Like 4 was the number we just used in the example. The second number, max, you're promising the compiler that the loop will never iterate more than this number of times. And then the last number is the multiple. You're telling the compiler that the iteration count is always an even multiple of this number. And that can become important in cases where the compiler wants to automatically unroll a loop or vectorize, things like that. Which loop does this apply to? The very next loop in the source code. All right. Now these properties of the loop iteration count that you're telling the compiler, they have to be correct. And they have to be correct for every call. Okay, it's very typical of a function for an integer parameter to be passed in and that parameter to be used to say how many times the loop runs. And so you can imagine that this function is called multiple times with different values for that parameter. And whatever you say in the must iterate pragma or attribute has got to capture what happens for every call. It's got to always be correct because the compiler cannot verify the correctness itself. The compiler is just blindly accepting that these properties are true for this loop, and then it's moving forward. If it turns out that you get this wrong, you're in a really bad place. It can be really hard to debug this. You don't want to get this wrong. It's the code that gets generated when this is wrong is, it's just not going to work. It's going to compute the wrong thing in a really big way. It's a bad thing to do. Please avoid it at all cost. In the example in this video, I used a minimum iteration count of 4. I just wrote 4 there and ended the attribute as the syntax I used. I want to emphasize that that was an exercise just for a demonstration, just for this video. That is not typical of how you would do it in actual code in real life. And in actual code in real life, you want to give the compiler as much information as you can within the bounds of correctness as I've already talked about. All right. So if you know that the inner loop will always be many more than 4 times. Say you always know it's 32 or something. Well, then say 32, okay? Say what is. Don't try and work out as I did in this demonstration. Well, what's the minimum I could possibly get away with? Don't go for that. Go for what is a number that is correct for every call, that really describes what's happening in your specific case. Now, the description of the must iterate pragmore attribute that I'm giving here is incomplete. There's a lot more to it that is covered in the compiler manual, so I can't encourage you enough to please go search for must iterate in the compiler manual and read about it there. I want to close this video with two references. The first one is to this web address right here. That can be a little bit much to type in. If you don't want to type that in, then search the internet for C7000 compiler. I have tried this search with a few different search engines. I always get this web address as the first result. This is how you get to the home page for the C7000 compiler. It's where you can download it, access the manuals, and more details like that. The second reference is to e2e.ti.com. This is where you can ask questions on any TI product, including the C7000 compiler. Compiler-related questions that are posed on the forum like this are answered by me. Thank you for watching this video in the series about the C7000 compiler.